to programming. So I'm going to show how to make a part. Just going to do some of the toolpaths here. It's a pretty complicated part, so I'm not going to be able to program the whole thing. But I went ahead and have laid on some toolpaths. This is basically showing you a Haas UMC-750. So this is a universal 5-axis milling machine. And what, for the most part, people just use these 5-axis machines for 3+2, so indexing. Rotate a part to a certain position so that you can take a cut and reduce setups. And you can see if you were making this part on a vertical milling machine, this would be 6, 7, 8, 9, 10, 11, 12 setups at least. So we can save a lot of work by doing this on a universal 5-axis. And then I'm going to switch over to Tim, and Tim's going to stay on the same theme, basically indexing, multi-axis programming. Tim's going to show as a part setup on a tombstone. So we'll get over to that shortly. So just to get started, what I'm going to do is go ahead and select the job here and click on my CAM tab and get back into a stock simulation. And I'll slow it down a minute here and just kind of show you guys what we're doing so far. So we've got the part mounted up on the machine, coming in on the top, doing a facing cut, contour cut around the outside, just to rough and finish the rectangular portion of the part. See, we've got the part held in a dovetail fixture. This is a pretty standard work holding for a 5-axis machine. It's one of the nice things about 5-axis. Not only are you reducing setup time machining the part on multiple sides, but you can reduce the documentation. So you can imagine how many setup sheets you would have to make to actually output this part, especially if you're programming the part and then you're giving documentation out to a setup person or operator on the floor. So a lot of that documentation goes away. It's just they take this size raw material, cut this size dovetail, mount it up, and push that green button and go. So we're doing an adaptive clearing here to rough out the pocket. And Tim and I's favorite toolpath there, a horizontal, 3D horizontal that just automatically finishes any flat surface it sees and also finishes the vertical walls that are attached to that flat surface. So all of those surfaces in purple are being machined with one toolpath. Select a tool and click OK. Drilling and tapping 256 threaded holes. And then here comes our tap. And then what I've programmed on the front side, just to give you a quick demo, is coming in and doing this pocket work and drilling and tapping some holes on the side. And machining that little angle just to give you an idea of how we would do that. Now, what does that look like on a CNC machine? Let's take a look. I'm going to select the job, right mouse click, machine simulate. And we'll get an idea of what this would look like on a 5-axis machine. Kind of speed it up to get through things here. So roughing the outside, roughing and finishing the outside. tapping the holes on the top, and now rotating over, doing the pocket work. Now, as this is live TV, and I usually work on these things the last couple of hours before the webinar, you see the tool holder has turned red, and this indicates there's something wrong. Now, this could be an over travel, meaning that we would have to use a longer tool holder, although I don't think that's the case looking at the spindle nose, so I need to do a little bit more research into this particular part, and I just ran out of time to figure that out. But it gives you an example of what machine simulation can do. And it could just be that I don't have the travel defined correctly in the machine simulation. So I'll figure that out sometime this afternoon. But again, that would be an indication for you if you're programming this part that something's wrong and something needs to be adjusted. We're supporting probably 10 or 15 customers right now with this exact machine. And I'm going to show you in a minute. I think you're going to be surprised at how easy it is to actually program this part.
Yeah, has been my experience. A lot of people are intimidated by 5-axis programming or honestly even 3+1 programming. And after you see how easy it is, I think it should dispel a lot of that concern that people have.
Exactly, and just showing that really the machine simulation is handy just for showing you what that looks like on the excuse me, on the CNC machine. So, and if you're noticing there, I'm opening another window. So the way our machine simulation works is that the machine assembly is a SolidWorks assembly. And when we choose a program to machine simulate, the system will actually open up a second SolidWorks window. It'll bring in the assembly, and this would be a topic for another webinar that's a little bit involved. But basically, we mate up our working assembly here and attach it to the machine assembly, and then we can simulate what's going on. So pretty straightforward. So let's take a look at what we're doing here. So the first thing we're doing is we're machining the part from the top down. So we've done a standard facing cut. Nothing fancy here. If I quickly simulate it, it's just your standard face cut. I think it's a 2-inch diameter shell mill. And I think that most people who are here today already have a basic understanding, so I'm not going to go through each tool path in detail. But I'll just give you an idea of what I did, how I built this part. I did a 2D contour here. I was actually playing around with this. There were some I like to use 3D toolpaths whenever possible just because it's so much faster. And I did do this. I was able to rough it out with a 3D adaptive clearing. And then I was actually able to finish this out without selecting any job using a 3D ramp, which just ramped around the outside of the part. But what I didn't like about it, and I think you guys probably wouldn't like about it either, is that you see these little sections here. It comes around and then it would dip in to just cut a little section here. And really I just wanted a nice rectangular cut. So this is one case where I went back into SolidWorks and I just created a sketch really quickly to define the outer shape of the rectangle. And so when I went into my 2D adaptive contour, I actually picked that rectangle. So far in this job, that's the only piece of geometry I picked that wasn't just part of the model. So sometimes if you want to do something that is different than what the model displays to you, you may have to create geometry to make that happen.
Nice thing there is that you have the powerful sketch tools of SolidWorks or Inventor, and then you can still tie them into the solid model, right?
Exactly, absolutely. So I mean, going in there and creating that sketch took me probably a minute, if that.
Yeah.
Okay, so the next thing, I did use a 3D adaptive toolpath, and this is basically a toolpath using a 1/8 diameter end mill. And then I went in, I selected a machining boundary, so I clicked around that boundary to keep the toolpath inside of it. And that was about it. There's our 3D adaptive cut, and that is roughing out, it's just roughing out everything it sees that's inside that machining boundary. And then I placed a horizontal cut, which is again just from the 3D milling drop-down menu, horizontal. I love this toolpath. I know it's one of Tim's favorites as well. So we just say throw a horizontal toolpath on there. It finds everything that's flat. And I think you'd agree if you're programming this using 2D toolpaths, it's going to take quite a few mouse clicks and potentially drawing extra geometry to make that happen. So 3D horizontal toolpath, one of my favorites. Drilling, or spot drilling first, drilling and tapping the hole. And then we finally get to the part where we are machining on a different side of the part. So how do we make that happen? I think you guys see how we machine top down. It's pretty straightforward. But how would we machine this pocket on another side of the part? So let's take a look and see if we can do it. So I'm just going to, this is just a simple 2D pocket. So 2D milling pocket. Now, I haven't defined any construction planes or any work coordinate systems in this case. We just originally modeled this up around, if you can see the origin down in there, it's a little blue dot. In this case, we did select the center line of rotation for the 5-axis universal machine. And that's just the way I happen to build this setup. If you're using the Haas UMC, which is what the demo is built around, it has dynamic work offsets, so you could just put your origin on the corner of a part and probe it, and everything just comes out right. So you don't really need to think about how you're setting up your origin or how you're setting up even work coordinate systems. HSMWorks is really smart about how it does that. So I'm not going to change planes. I'm not going to do anything. I'm just going to literally tell it to do a 2D pocket. It already has a 1/4-inch diameter flat end mill selected. I'm going to go to my geometry tab, and right now it's remembering some previous selections. So the first thing I like to do is basically we always want to check this tool orientation box. This is the checkbox that says I'm not working on the top of my part anymore. I'm working on a different face of the part. I'm going to delete the selection. It was thinking for me and pre-populating. So now this is SOLIDWORKS functionality. So whenever you see a box that is highlighted the color blue, it means it's ready for a selection. So I'm just going to pick a face. And that says now I'm working on this face. Start cutting things that are on this face. And then I'm going to click up in my model tab here, and just because I'm using a 2D adaptive toolpath, or sorry, a 2D contour, I'm going to chain around there. Usually it'll chain in one click. In this case, I see what's happening. So you can see because it's intersecting this flat, it didn't have quite enough information to know exactly what to chain. So I'm going to have to chase this around a little bit. And remember, guys, this is live TV, and I have not actually practiced this part of the demo yet today. So you guys get to see it go live. So as you can see, I've picked a pocket, or defined a pocket. I've selected my tool orientation. Take a quick look at the heights tab. So we're cutting from the model top to a selection. So again, it's probably remembering a different selection, so I'm going to delete that and pick a new selection. And you see this little blue plane slices through and gives us an idea of how deep we're going to cut. I'll take a quick look at my passes tab. Point one step over, looked fine. Let's see what we get. And then we do, in fact, have a facing toolpath. So that, ladies and gentlemen, is literally how easy it is to create a toolpath on a different side of the part. We can post-process this code, and the post-processor and the machine controller will take care of everything else. We don't need to think about what's going to happen, how that table's going to turn out. So let's take a moment just after doing that one toolpath, and I'll take a quick look at questions and see if we have any questions coming out. And of course, if we do have questions, now's your chance to go ahead and ask them. Just drag this over here so I can see it. So Tony's asking, how do you avoid fixtures? Well, it's not going to automatically avoid fixtures, although what you can do in your job setup, and I kind of skipped over my job setup, but we know that we always pick a minimum of 3 things in our job setup. 1 is our working model, 2 is our stock, and I have my stock invisible right now. I can show that to you in a minute. Basically, I did model up a piece of raw material with a dovetail feature on it, and we always have to define our work coordinate system, although in this case, I didn't create a work coordinate system, so it just defaulted to the origin in the file. I usually do create a work coordinate system. And then we've got the fixture defined here. So the system will not automatically avoid fixtures. If you tell it to drill 10 inches deep down into this fixture, it'll do what you tell it to do, but it will give you a warning when you go to stock simulate that you have hit the fixture. Would you agree with that, Tim?
Yeah. There's some tricks you can do. You can I know in the past I've like modeled in clamps and called those parts. So make the part basically a little bit bigger than the actual clamp. You could do that for that dovetail fixture, so you can machine it all the way down to that kind of fake fixture. That's a good way to do that and make it somewhat of an automated thing. Having containment, sketches. You could put in this part. You could put a containment sketch kind of window from one angle and another one from the other angle, and that would help you define, machine everything inside of this. So you could have it, say 100 thousandths away from your dovetail fixture, on that side, but then you can have it wide open on the others. So if you're doing like a 3D adaptive, you could contain it within that sketch, and it'll machine everything. And when we get over to mine, I think I did that, and I can show you that.
Okay, perfect. So we're looking pretty good here on time, and if you'll see there, I just made that this translucent model is the stock that I defined. So what I usually do in a situation like this is I'll take my part, I'll position it where I want to using SolidWorks assembly features, and then I'll draw up my material block based on a good accessible material size, and then I'll take the dovetail geometry from this fixture and actually use convert entities to put it on and actually model up that dovetail. That way you've got a part model of that pre-selection. I don't know if you guys can see in there, we've got a dovetail feature, and then we've also got a slot cut so that it just locates on that locating feature on the dovetail fixture. In this case, this is a Raptor dovetail fixture. So let me try and just throw on a couple of other toolpaths just to illustrate what we're doing, and then we'll go over to Tim and we'll look at Tim's setup. So I'm going to go back into SolidWorks, just make my stock invisible, just helps me kind of select things a little bit easier. So let's say if we want another sample, how about if we take a look at this flat surface and then this hole? And now we're getting into the realm of the unpracticed area. So again, it's live TV. Forgive us if it doesn't go completely right. So it looks to me like this is still a 256 diameter tapped hole. And certainly we can do that for the purposes of the demo. So let's say, we've just machined this pocket, and we've decided now we want to machine this section here. The way we would do that is I'm going to go with just a 2D milling face cut. And I'm going to stay with my 1/4 inch diameter flat end mill. I'm going to go into my geometry tab. Tool orientation is already selected. I'm going to deselect the face that's picked for me. And I'm going to pick a new face that says, hey, that's where I want to work now. That's my working plane. I remember doing this on the other side, and because it sees the stock material and the part, it's going to face off a bunch of extra material that we really don't need to because we've already machined it from the top. So I'm going to go ahead and just define a stock contour here that just says kind of stay in this area. And let's try that again because that did not work. So I want that one, I want that one, I want that one, I want that one. There we go. That looks like a good area to stay within. And my default behavior in HSMWorks is click OK and see what happens. And a lot of times it works just fine. I see that. It looks like it's machining the part okay. I'd like to go from, instead of like top to bottom like that, I think I'd like to go from side to side. So I'm going to edit the cut, go into my passes tab. I'm going to change that cut angle to 90 degrees so it's running this way. That way it's not running towards my fixture. Click OK, and we've got a tool path there. And simulate that. And we're cutting at that angle. And I see a question coming in from Tony. We'll handle that in a minute there, Tony. We'll take a look at that. So let me just go ahead and define this hole. So let's see what I've got here. So this diameter is, go ahead and pick that cylindrical face and see if I can get a measurement there. Diameter 0.187. So, you know, I could plunge that with a 187 diameter end mill. Why don't I just pocket it with a 1/8 end mill? So let's go 2D milling, 2D pocket, pick a tool, 1/8 flat end mill. Now here's a case, you know, on these 5-axis machines, you definitely do need longer tool holders to do some of these things. And in this case, I haven't set up the 1/8 end mill in a long tool holder, so it might yell at me a little bit when we do the machine simulation, but I think for the purposes of demo, it's okay. So I'll select that tool. I'll go into stock, into my model definition. Again, this time it's populated the correct face. I'm going to go ahead and reselect anyway just to give you another way to do it. So a lot of times if you're just drilling holes, what you would pick instead of a face is just a circular face, and now it still understands what part you want to work on. As far as picking the model, now I'll go ahead and pick the hole that we want to drill. I'm sorry, actually that's not the one we want to drill. We want to, because we're doing a pocket, so that's where we want to pocket. From a model top, I can give it a selection for how deep I want it to go because I'm not sure what it's picking there. We can see there, that's how deep it wants to go. And let's see if this is just going to work first time. We'll just click OK. And because it's live TV, it didn't work first time, so we've got to go figure out what that problem is. First thing I'm going to check is to go into my passes tab. And this is probably the problem. You see that my step over is set as 0.1. We know that with a 1/8 end mill, we can't step over that amount because it's just going to blow that hole away. So let's make that a small amount. Let's take 20 thousandths and see if that solves it. So it still doesn't like it. What else could it be? I'll go to my heights tab from model top to depth. That looks okay. Not leaving any stock to leave. Passes looks okay here. So potentially something in here. So when your tool path does not work, it tends to be, that's what I look at first, the step over. And then the next thing I look at is the default behavior is always going to be a helix entry. We could potentially just change that to plunge, and that might solve it. But one thing that is often the culprit is this minimum helical ramp diameter. So it's going to take a helical entry, and we're telling it that it needs to ramp in with a diameter of 118. That's just a default number. I think that number is just too big. It can't handle it. So again, for the minimum, this is the minimum number, I'll let it ramp in 20 thou. And let's see if that solves it. And that doesn't solve it because it's live TV. So,
hey Derek, I click on that and then show log and see what that says.
Okay.
Don't generate passes. There you go.
Sometimes that log is helpful, sometimes not so much.
Yeah.
What else could it possibly be?
So go to the geometry tab, please. So what did we do there? So let's clear that. Yeah, let's clear that out, and just select the contour on the bottom and see what that gets you.
Yeah.
And then yeah.
There we go.
Yeah.
But I think what I had done there is I had picked the face, and we could pick that face if the tool would fit within that donut shape, but because it could fit that just that flat land.
Yeah.
Yeah. So usually between those three things, you can usually figure out what's going wrong with your process. So we've got that pocket done now. So we've got a facing cut and a pocket cut. And let's go ahead and drill and tap these holes, or this hole. In this case, it's still 256. Now, something I was playing with earlier, and I might as well show you, is when I created a 256 tapped holes earlier, I saved those out as a template. Because if I'm going to create a lot of drilled and tapped holes or any kind of feature, it often works the same way. So instead of just doing it from scratch, I'm going to right mouse click and I'm going to say create from template. And I'm going to pick my 256 tapped holes. And you'll see it's populated the spot drill, the drill, and the tap. Now we'll still need to go in and pick geometry. So let's edit that cut. And I like to save it out because it's going to remember all the parameters that I've set. And the only things I'll need to change is tool orientation. I need to let it know it's working there. What holes are going to drill? Again, I'm picking that cylindrical diameter. I'm going to make the same change for the remaining two cuts. So tool orientation, that, and the hole we want to drill, which is that, and OK there. And same thing again, right mouse click, edit. I always pick the tool orientation first, not the geometry, because sometimes it breaks if you first of all, you need to let it know what side of the part you're working on. Then you can tell it what geometry. And click OK there. So if I highlight just those tool paths and do a simulate, you see that we're doing a facing cut, we're doing a pocket, drilling and tapping the holes. And again, with just those tool paths selected, I'm going to right mouse click and pick Machine Simulate. And you'll see that it's working on this side of the part and doing its job the way it needs to do it. Okay, so hopefully this little demo gives you a good idea of how to program that machine. And as long as you have the correct post-processor, any other 5-axis machine where you're just programming 3 + 2 is going to work in exactly the same way. Once we get into actual 5-axis simultaneous machining, that's a different subject for a different day, and rest assured we will put on that webinar. So let's see if we can answer a few questions quickly, and then we'll move over to Tim's show. So Tony was saying the previous face toolpath would cut into the fixture, so not that one or that one. I'm not sure there, Tony. Which particular face toolpath are you talking about? Or maybe you're thinking of this contour here where I did just a contour cut around the part. So I got the rectangular done from the top. If I were to just tip it over and say face one of these sides with a facing toolpath, yes, it could potentially hit the fixture, so we would need to think about that. Yeah, I see you. So you
on the part I'm working on, I can show a good way to control that.
Okay, perfect. So Tim will show that in a minute, and Anthony said there, yeah, he was talking about the side B90. So we'll get to that in just a minute. And then let's see, so Tom was asking, could you walk through creating a template? So yes, we can. And I think Tom,
let me jump in here. This has got to be probably one of my favorite features of HSM is how easy this is to create. So I'll go ahead and after that.
You want me to switch to your screen, Tim?
The drill, this is a perfect one to do it. So I would just say to do that here.
Yeah, I didn't catch that. Did you want me to switch to your screen, Tim, or do you want me to
I would say drilling and tapping is a perfect example. So if you want to just do that with this part, that'd be great.
Yeah, okay. So selecting those 3 cuts. So, you know, we're spot drilling, we're drilling, and then we're tapping. And, you know, this is a perfect example because there are a bunch of holes on all different sides, and they happen to be all the same thread depth. So once we've got it dialed in the first time, we can just right mouse click, pre-select or control select the operations that you want to create a template for, right mouse click, and say store as template. And in this case, I just so happen to have already done it, and it's just defaulting to an HSMWorks templates folder. Obviously, you can create different folders if you start to create a bunch of templates. Certainly, when you have families of parts, or you know, similar operations on different parts, these are great examples of times to create templates. And it's just as simple as that. We've created a template. And if I was going to drill and tap a new section of holes now, I would just right mouse click and I would say create from template, and I would pick the template that I created, and I could either just pick one of these at a time, or clicking this top selection will create 3 new drills and toolpaths. So good stuff. Sounds like Tom's happy with that. I was going to say a minute ago, Tom is one of our customers who actually has a UMC-750 and has been programming it successfully, literally, I mean, within a few days of the machine being installed. And then once Selway gave Tom the training, I think Tom would agree, you were up and running really quickly. So fantastic. Okay, guys, I'm going to go ahead and switch this over to Tim. We have 20 minutes left. We have a hard stop today at 1 p.m. because I have another online meeting to jump onto. So hopefully I haven't used up too much time. We'll switch over to Tim, and then as soon as Tim's done, we'll hopefully have a little bit of time for any more questions. So Tim, if you're ready, I'm going to go ahead and change over to you.
Yeah, I'm ready.
Okay. And I'll let you know once we see your screen. Right now we're seeing, there we go.
Isn't that good?
That's perfect. Okay. Yeah.
So real quick, last week I was happy to join you, and we went over some advantages and efficiencies of things like 3D adaptive clearing, rest machining, 3D horizontal. toolpaths, and those are all posted on Derek's YouTube channel, so I would check those out. This week, we're going to highlight a couple things you can do kind of to follow what we talked about last week, was some using 3D toolpaths to not necessarily make a 3D surface, but maybe eliminate another job setup. So we're going to go over that, and then while we're doing that, we'll just keep it short, maybe show a couple different ways you can pattern toolpaths. So we'll get back to answering some questions. So dive into that. This is a horizontal setup with a tombstone. We have some 5-axis work holding vices, and we won't get into the second operation of this, but this would be a typical setup on a horizontal to make like electronic enclosure, something that's still pretty simple part, but a lot of different setups. So we'll jump right into that. We'll kind of go backwards from, I haven't fully programmed this. I kind of didn't have a lot of time to set up for this before, so I just wanted to show what you're able to do in a part like this. If you're going to put in a 3-axis machine, you're going to come in and machine this, maybe hit these holes, rough out whatever you can. But often you would have to look at the part from this angle to maybe side machine a feature like this. This is really common in aerospace industry, where a lot of people don't think about 3D toolpaths as something that can come down from here and do a very simple 3D toolpath to make a feature like this. I mean, you can also do it, if you're looking down here, you could take a ball mill and finish that. So we'll walk you through what we did, and then I'll show you how to easily pattern that around this tombstone. So what we've got here is a flow toolpath. It's actually one of my favorite, especially for doing something like this. So I'll just add another one. I'm going here to new operation, 3D milling. I just go right down to the flow mill, or flow toolpath. And we'll take our 1/4" ball mill. And then in the geometry tab, you just have to select the geometry you want to run the 3D toolpath on. And it's pretty much that simple. Here, that's going to take 1 pass. That's the number of step overs. Usually throw in a big number, like Derek was saying, just to kind of hurry up and get to the toolpath to see if it's what you want. And what you'll see with this orange check mark is if you go into the show log, it'll say 1 or more passes were completely skipped. That's because in that area it couldn't really put and link together well 20 tool passes, or 20 passes. It's fine, it's still going to cut well. So a lot of times I just throw out a big number, see if it looks like I want. Maybe I'll simulate it, see if it's, the scowl types look good, and then I'll run with it. A lot of times a feature like this isn't a necessarily cosmetic feature. There's no real tight surface finishes on them. So that's what I did here. And you can see how I did like if you go to the linking tab, you can see I had it pick shortest path, so it makes them efficient. It's not retracting way out. And I'll delete this and show you how I duplicated that. Our duplication tools are really nice, our pattern tools. So what I did is you just, highlight those and go up to duplicate or pattern. And inside your pattern, you have some options. These are all good. A lot of people use linear or circular or mirror. These are probably the two that I use the most, duplication and component. So on this one, I picked duplication, and then I'll show you what we did here. Clear that and clear this. So we start by picking, you pick that, like, hey, this is the part that we put those toolpaths on. You can see I put it on both sides. Now I want to take that and throw it on that part, and I want to throw it on that part. and that part, and that part, and that part. So very quickly and easily throws them around the rest of the everywhere they're at, or everywhere you select. If you wanted to do another option there, if you highlight those, go to pattern. This is for a drill that I was doing. The problem that going to pop up here for component pattern, which is one of my favorite, is that everywhere it finds that component, it's going to put those same drill holes. So if you see, if I click on that, it populates it everywhere. The problem is it also populates it here on these, which we already did them on. So on this case, it's probably better to do a duplication, just run around and grab them. That's a good way to do that. I'm just going to keep it pretty simple, and we're going to get to that avoid fixtures question. That was a great question, and something that's a very real-world, question or problem, especially when you have, holding on to things with expensive fixtures and tools. So what we did here, I started working on a 3D adaptive toolpath to clear out this whole area here from, you can see coming in from the side here, and you're going to have to come in and do it from the other side because we have, as you have these areas here, you're going to have to machine out. So what I started, and you do the same thing for 3+2 or 5-axis machining, is I went in and see this containment sketch that I created. We'll turn it on so you can see it. I made a parametric sketch, and see I just dimensioned it. I did it 30 thousandths of an inch off of my vise, and I let it go an inch out this way, an inch out this way, an inch out this way. And the inch was just really to go further than the tools that I'm going to use. So I don't care if it comes out here. I just don't want it to go closer than 30 thousandths to my jaw right there. So that's how I did that. Let's close that out. So then when you're in the toolpath, you grab your tool, and then here in your containment, you just grab that containment sketch. So before I jump into a job that has work holding like this, I might put a containment sketch here, and maybe on this surface too, on this view. So I'll do one here and do one there, and those usually handle all the containment that you need to do. So that's a good way to keep your tool off your fixture. And then if you wanted to see how close it gets, you can grab the job, right-click on it, and hit simulate. And then you just come in to where you look and try to find the closest little node right there. See how the gray bubble pops up. And that'll show you we're getting close, but like one of my old bosses used to say, we're thread needles with hand grenades, and clearance is still clearance. So you see there, we're off the part, and we're still machining to our intent. So that's a good way to avoid fixtures. And that would have worked on the same setup that Derek was in. So there's my favorite toolpath, the 3D horizontal. And that's kind of a quickie. If anybody has any questions, throw them our way, and we'll answer them.
Okay, awesome. So let's see, we got a couple of questions coming in here. Let's see, coming in from Tony, can you flip the direction and have come off the part in a linear step over? So we're going to take you back about probably 4 or 5 minutes. So I'm not sure. Oh, off the flow tool path. Tony just clarifying there. So on the flow tool path, change direction.
So for here, I want to change direction. Meaning, so we started at the bottom.
Instead of running, that, or actually instead of running up and down, what if you run them side to side? So you just
great question. Yeah, great question. So you see these arrows here, they actually followed the way I probably wanted to go. Usually like the tool to go whatever the longest way is, but that's a great question. So we'll go through the selections on this. So I just cleared that out. And you're going to grab the selection here, and if you see that arrow, you're just going to flip that direction, and you're going to flip that direction. Same thing here, and same thing here. So now you'll see, now it still does those 20 step overs, so if you wanted a finer finish, you would just go here and say 40, right? See what it actually does is it puts 40 passes here and 40 passes here. So if you wanted to have fewer here and more there, you just break it up, duplicate that, clear that, select this, and flip it, like that, and flip it. And then I would go back in here and create it as a separate, maybe there, flip it, there, flip it. And I know that's a 130 radius, and I've got a 1/4 inch tool, so we really need maybe 2 or 1 tool pass in there. So that's probably more than sufficient. Does that answer that question?
I think that does, yeah. So Tony, let us know if that does or doesn't. And then obviously there are, other potential tool paths you could use as well. So a flow line for me is really, it's a great tool path when you just have like one surface or a couple surfaces connected. If you've got a whole body to machine, you'd probably use a different strategy.
Exactly, yeah.
Yeah, that was good stuff there. Question coming in, tool holder avoidance in simulation, question mark.
Tool holder avoidance and tool simulation. So a couple, before I jump right to that, one of the things I was going to say is often you kind of know you're getting close. So you can do the simulate like I was already talking about. You can do that. And then you can come in here, click on a node, and this is actually pretty close, and that's why I picked that tool path. You can see it's starting to get close, but you can push play, and you can kind of just watch it real quick. It doesn't alarm, but it gives you an idea that you can at least move forward before you get to the simulation. Now, if you wanted to do a simulate, you go to stock simulate. It's probably going to take a minute on my portable laptop to do the full assembly because I do have fixtures tied in there. But I'll show you where that is. So you can do it in stock simulation or you can do it in simulate. But there's a box that you would select for tool crash detection. And you have to just make sure that you accurately model your tool holders. One way to get probably maybe a more efficient way to avoid like your spindle crash without having to do a whole machine tool simulation is, sometimes it's appropriate to model in your tool holder the spindle nose itself. So I've done that with like a rotary or a 4th axis. But right here, you just say stop on collisions, and if your tool holder hits anything, which this didn't really get roughed out well, so you're going to see here saying that my tool flute is crashing because we didn't go through the roughing cycle first. But if your tool, if you put it here for check against fixtures, your fixtures will come in, and if your tool holder hits your fixtures or anywhere else, you'll get this same event box that will pop up and alarm out for you.
Right.
Does that answer that?
I think that answers that. So we have tool holder collision in stock simulation.
Yeah.
Okay, and then Tony was following up on that. You made the bounding box for the tool path, but what about the holder? But I think the answer there is that containment boundary is going to contain the tool itself. It's not really going to, when it's creating the tool path, it's not going to take the holder into consideration. But when you stock simulate, if you are colliding, you would get that warning. Would you agree with that, Tim?
Correct. Yeah. So what that boundary does, it doesn't let the tool go outside of that sketch. So then you simulate it, you turn on the collision warning against the fixtures, and if you had a short holder or whatever and it hit, say here, you would get that alarm that popped up.
Right. Okay, I have a question coming in from Tom. Does the new version of HSM support importing external 3D models of tool holders from the tool manufacturer?
I would have to get more details on that, but I knew we are working with both cutting tool manufacturers and tool holder manufacturers. I'd be happy to answer that. I don't want to shoot from the hip, so maybe if we can get your email, I'll see the example that you're talking about. But that's our long-term goal, is that we'll have all of the tool manufacturers, holder manufacturers. We'll have libraries of those. But for now, I think there is some importability, but we would have to see the files that are coming in.
Okay, so we'll check on that. We'll do a follow-up on that answer. And I've got a question coming in from Tony. When you do a pattern to the next part, is it posted as a sub or as a main program?
You want to answer that one, Derek, as far as the
Sure.
programming goes? I mean, you can definitely have it as a single.
Right. Well, it will output as code. It will, if you're just using a generic post processor, but we have developed post, so we handle it within the post processor is the answer to that, because some people do want to have subroutines for the additional parts in the pattern. So yes, we can output it as subroutines, but it takes some post customization, and we do have a team who will do that, and yeah, it's doable.
Yeah.
Okay, so I have a question from Henry, and we're getting close here. So let's see. How do we access the video recording YouTube channel? Check your email, Henry. I will send you an email. Usually once I get this processed up, it's usually, it takes me a day or two by the time we process the video, get it uploaded and all that good stuff. But I will send out a link to everybody with a link to this video and last week's video. And if you got an invite in your email to this webinar today, in that same invite is already the link to last week's video. So, okay, everybody, we're down to about the last minute or two. So if you do have any questions, go ahead and put those in right now, and then we've got to jump off. We've got another meeting to go to. Glenn's asking, do you have the above models? So actually this is coming in an email. Glenn's asking if we have the Kurt Weiss and the Haas Super Mini Mill. I know that I have the regular Mini Mill, Glenn, so I'll go check on that, and I'll take a note here to send you those models. And then as far as the Kurt Weisses, I believe you can navigate to Kurt Weiss and download those models directly from the Kurt website. So we'll send you those.
I've gotten those off of Kurt's site.
Okay. And then just taking a note, Tom's question about when we're going to have solid tool holders. And I believe that's, it's a question of when, not if. But we really don't know what the priority level on that is right now, whether it's 2 weeks from now or 2 months from now or 2 years from now. So we'll check with the product manager, and we'll get a good answer to that. And let's see what else. So basically, as always happens, right about 1 o'clock, we get a lot of people dropping off. So we've got people getting back to work. A lot of people saying thank you. So thanks, Tim. I do appreciate your time. And thank you, everybody out there. We do realize that you're investing your time to be here with us on a Friday afternoon. So we do appreciate it. I'll go ahead and close this out for now. So thank you, everybody. Thank you, Tim, for participating. We appreciate it. And
thanks for the invite.